Today's lesson is from Chapter 18, Section D, and it's about exponential growth and decay. We're just going to work through a few example problems that have to deal with growth and have to deal with decay. You can tell that something is growing because when you have a to the x, the a value is going to be greater than 1. And you can tell that something is decreasing because when you have a to the x, the a value is going to be between 0 and 1. Alright, here's an example problem. An entomologist, that's a scientist who studies bugs, is monitoring a grasshopper plague. He notices that the area affected by the grasshoppers is given by the following formula. A of n equals 1,000 times 1.15 to the n hectares. And in this problem, n represents the number of weeks after the initial observation. So question A, find the original affected area. Well, in this case, think for a second, how much time will have passed when the biologist first sees the plague? Well, 0 time. 0 time has passed. So you can use the equation and you plug in 0 for the number of weeks because 0 weeks passed. We know that anything raised to the 0 power is 1, so the answer here is 1,000 hectares. Part B. In order to find the affected area after 5 weeks, again we'll use the same equation, 1,000 times 1.15 to the 5th, because that represents the number of weeks equal to 5, and we end up getting 2011.35 hectares. And then part 2 of that would be after 12 weeks, so same thing, 1,000 times 1.15 to the 12th, and we get 5,350.25. For all of these, you should probably round to 3 significant figures, unless it says otherwise. So for part B, for the first part B, that would basically end up being 2010, and for the second part of part B, that would end up being 5,350. Alright, as we move on, now we get to the part where it says to draw the graph. This is where you actually need to be pretty specific. So you're going to want to make sure that you are aware of some of the data that you've already found. So first, you already know 3 points. So we're going to list the points that we know. We know the point 0, 1,000. We know the point 5, 2010. And we know the point 12, 5350. So we already know 3 specific points. Now I need to choose my scale and graph it. So I'm going to draw my set of axes. So I'll draw my scale going up to 12. So this middle would be about 6. The middle of that would be about 3. So that's 1, 2, 3. 4, 5, 6. Middle of that would be about 9. So 6, 7, 8, 9, 10, 11, 12. Then for my y-axis, I'm going to go ahead and count by thousands in this case. So this will be 1,000, 2,000, 3,000, 4,000, 5,000. And I'm going to label the axes with their variables. So this is n, and it's measured in weeks. And the y-axis is the area, and it's measured in hectares. And now I'm going to plot my points. So my first point is at 0, 1,000. My next point was at 5/2010, so 2000, just a smidge above that. My third point was at 12/5,350, so 5,000, so maybe just about slightly less than halfway. So that's my curve, and I actually am going to connect the dots with a smooth curve. Alright, and there's my graph. Okay, then we get to part D. How long will it take for the area affected to reach 10,000 hectares? So we don't have that on our graph. If we had a much better graph, we could figure that out. But what we're actually going to do is we'll write ourselves an equation. So we've got 10,000 is going to equal the original equation, 1,000 times 1.15 to the n. Because what we're interested in is how many weeks until the area equals 10,000. In order to solve this, we'll use our calculator. So we set the y1 on our calculator equal to 1,000 times 1.15 to the n, or x on our calculator. And we'll set the y2 equal to 10,000. So going to y equals, I need 1,000 times 1.15 to the x. My y2 is going to be 10,000. I'm going to graph those. It's a pretty slim chance I'm going to be able to see them, given that we're basically, we need to go up to 10,000. So I'm going to change my window. There we go. X min, Y max, that's probably alright. I'm sorry, X and X min, X max, that's probably alright. So let's go to our Y's. We'll stay with -10, and then we're going to go, let's go to 20,000. And we'll count by thousands. And let's see if we can see our graph that way. So it's graphing slowly. You'll notice we're off the screen. So let's set our window again. This time we want our X max to be bigger, so let's make that 100. And let's count by tens. And we'll graph again. There it is. And now we need to find the intersection of that point right there. So we do second calc. We choose 5 for intersect. We use our cursor. There it is. So there's my first curve. There's my second curve. There's my guess. So my intersection is at 16.47. So in this case for part D, N is going to be 16.5 weeks. So it takes 16.5 weeks in order for the area to cover 10,000 hectares.